Now let's think about tracing matter and energy through biological systems. Matter and energy will both exist at the same time in these systems, but they do not convert into one another. Matter can change into other forms of matter, energy can change into other forms of energy, but matter and energy will never convert into each other in biological systems. Because of this, think about matter and energy separately for the following slides. Let's think about matter, or atoms, in an ecosystem. In this ecosystem, carbon atoms from carbon dioxide are converted into sugars by grass. Carbon was transformed from carbon dioxide into sugar. A grasshopper ate that grass, and carbon from the sugars was digested and assimilated into the tissues inside the grasshopper. A bird ate that grasshopper. The carbon that was assimilated into the grasshopper was digested and assimilated into the bird. The individual atoms of carbon that we're talking about, the matter, is changed into a new form, but it still exists in the system. Now let's think about the energy in this ecosystem. Solar energy from the sun struck the grass and was converted into chemical energy in the sugars it produced. The grasshopper ate the grass, and as the sugars were broken down during digestion, some of the chemical energy from the sugar was released as heat, and some of it's transformed into chemical energy in the bonds of the tissues that were created during growth. When the bird ate that grasshopper, the chemical energy from the grasshopper's tissues was released during digestion. Some of that energy was heat, and some of that energy was transformed into chemical energy in the bonds of the bird's tissues that were created. But remember, that energy changed forms as it moved through this system. It was not created or destroyed. So in this ecosystem, we saw that matter and energy both existed at the same time, but they did not convert into one another. The carbon from the carbon dioxide that was taken in by the grass was not turned into energy. The carbon from carbon dioxide that was taken in by the grass was converted into another form of matter. The carbon atoms were incorporated into sugar molecules. Similarly, the energy from the sun was not turned into sugar. The solar energy from the sun was transformed into chemical energy in the chemical bonds of the sugar. The transformation of matter and energy are actually two separate pathways, but they exist at the same time. Remember, when we're tracing matter through the system, we're talking about objects, the atoms. When we're tracing energy through the system, we're talking about the ability to do work. So as you're thinking about how biological systems are changing, remember to think about how matter and energy are transforming. When we're talking about matter, remember that we're talking about objects. Where are the atoms going? And remember that atoms can be rearranged to make new molecules, but they can never be created or destroyed. When we're talking about energy, remember that we're not talking about objects moving, we're talking about the ability to do work. And remember that energy can be transformed to make new energy types, but it cannot be created or destroyed. And think about this framework anytime you're faced with questions about change in biological systems. To explain the change, you need to be able to trace the matter in the system and trace the energy in the system. With that framework in mind, consider this question. Your friend lost 6 pounds of fat after exercising. What happened to the mass he lost? Select all of the correct answers. Did A, most of the mass eventually leave the body as sweat? B, most of the mass was burned up during exercise? C, most of the mass eventually turned into heat energy? Or D, most of the mass eventually got exhaled into the air? Before we answer that question, let's pause to watch a short video about what happens when you lose fat.
There are some things in life that when they're around, we wish they weren't there, and when they're gone, we're just glad they left. For many of us, one of those things is fat. But your fat tissue is full of important biological molecules called lipids, long, stringy compounds of hydrogen, carbon, and oxygen that are great at storing energy in their chemical bonds. When the molecules are broken apart, they release the energy stored in their bonds. We often refer to this process as burning fat. But when you burn fat, where does that material, the actual stuff that jiggles around and cushions you and insulates you, where does it go? Interestingly enough, a recent survey of doctors, dietitians, and physical trainers revealed that even the experts in fat loss didn't know the answer, although they thought they did. More than 50% of the respondents thought that when you burn fat, all that mass is simply converted into energy and lost as heat. It's a common misconception, but it's not possible. I mean, just because you don't like something doesn't mean that the laws of chemistry don't apply to it, and one of the basic principles of chemistry is the conservation of mass. This just means that the same amount of material always comes out of a reaction as goes into it. Even if that reaction happens to generate heat, you'll wind up with the same number of each kind of atom that you started with. So when you break up those lipids in your fat cells, cells and release their energy. All of that hydrogen, carbon, and oxygen in those molecules will still be there afterward. But if you burn a lot of fat, and it's not there anymore to hold your pants up or whatever, where did the mass go? Turns out, you exhaled it. Biologists at the University of New South Wales recently did an atom-by-atom breakdown of where the mass of your fat goes after it's burned in your body. They found that for every 10 kilograms of fat that you burn, you have to inhale 29 kilograms of oxygen to metabolize or break down the fat and release its energy. And the process of breaking down that much fat produces 28 kilograms of carbon dioxide and 11 kilograms of water. So for every kilo of fat that you burn in your body, more than 80% of that mass is lost as carbon dioxide that you breathe out. The other 20% you lose as water, in your urine, your sweat, or depending on how hard you work out, your tears. But if you do the math, you'll see that all the mass in that fat-burning reaction has been conserved. 10 kilos of fat plus 29 kilos of oxygen equals 39 kilos total, and together they produce 28 kilos of CO2 plus 11 of water, which also equals 39 kilos. So remember that the next time you're huffing and sweating on a treadmill or walking your dog or really doing anything that makes your body call on its energy reserves. You're basically just emanating fat through your breath and your skin, but in a good way.